In this section, we'll discuss the properties of definite integrals. So we go beyond using rectangles to find the finite sums, meaning we have used Riemann sums earlier in Unit 6, but this time we'll look at what happens in the limit as the terms become infinitely small and the number of rectangles approach infinity. And we said that this is the same as the area under the curve, the actual area under the curve. Okay. And we have also discussed about negative area. So we said that if the graph is above the x-axis, the area is positive. And if the area is below the x-axis, then the graph is negative. Okay, let's take a look at this definite integral notation. So this is the notation introduced by Leibniz for the definite integral. Okay, so this is read as the definite integral from a to b of f of x with respect to x. And these are the components. You have the upper limit is b, the lower limit is a, you have the integral, the function we're given is the integrand, which is really the derivative. The derivative. Okay, and the variable of integration here is x. And this whole thing is basically the definite integral. Now we use the definite integral to find the area, the net area or the displacement that's bounded by the x-axis, the function f of x, and the vertical lines x equals a and x equals b. Okay, let's review. In example 1, we are given the graph of f of x, which consists of these line segments and the semicircle. Okay, and the interval is from -8 to +13. Okay, we want to find the integral from 0 to 7 of f of x dx. So this is nothing but finding the area from 0 to 7. So this area right here, okay, from 0 to 7. And that is, let's review what areas we have here. So we have the triangle, and the formula for the area of a triangle is 1/2 base times height. The area of a trapezoid is equal to 1/2 times base 1 plus base 2, there are two bases, multiplied by the height. And then we have the area of a semicircle, which is equal to 1/2 the area of the circle. So 1/2 pi r squared. Okay, so from 0 to 7, we have a trapezoid. So that would be 1/2. And then these are your bases. So first base is 7. Second base is, so this is from 2 to 5, which is 3. And then the height is equal to 4. And that would be equal to 20. Okay, for B, we want to find the area from 0 to 13. So to this area, 0 to 7, we are adding on the area from 7 to 13. Okay, so that would be 20, which is the area from 0 to 7. That's your 20. Okay, and then since this is negative, since this is below the x-axis, that area would be negative. So the area from 7 to 13, again, that is a trapezoid. So we have 1/2. The two bases are, so this is 7, that's 6, plus this is from 8 to 11, so that's 3, and the height is equal to 3. And this is equal to 6.5. Now next, we want to find the area from negative 6 to 0. So this is this semicircle right here. Okay, and the formula for the area of a semicircle is 1 half times pi. Our radius here is 1, 2, 3, 3 units, so times 3 squared. That is equal to 9 pi over 2. But since that is below the x-axis, let's put in a negative in front. So we have negative 9 pi over 2. Okay, for letter D, you want to get the integral from 3 to 3. So remember that if the lower limit and the upper limit are the same, then there is really no area formed. So the area would be equal to 0. Letter E. From 7 to 0. So notice here that the lower limit is 7, the upper limit is 0. So that is the lower limit is higher than the that's it. Lower limit is higher than the upper limit. So we can switch this up. When you switch up the limits, then you have to change the sign, okay? Because you're going in the opposite direction. So the integral from 7 to 0 is the same as the negative integral from 0 to 7 of f of x dx. And this is one property of integral that we will look at again later. So we have negative integral from 0 to 7. We have found it in letter A. So that's equal to negative 20. Okay, for letter F, it's the same thing. The lower limit is higher than the upper limit. So we get the negative and then switch the limits. So this would be negative integral from 4 to 10 of f of x dx. And from 4 to 10, we have got this trapezoid right here. Okay, that trapezoid, so that area. And then this trapezoid here, that area. So from 4 to 7, the area of the trapezoid would be, where am I? 1 half. Oh, don't forget that negative. So negative, and then we have 1 half times the bases from 4 to 7 would be, that would be 3 plus 1, and then the height is 4. So 3 plus 1, and then the height is 4. And then we have to subtract the area of the trapezoid from 7 to 10. So that would be minus, again, 1 half. And then our bases are 1, 2, 3 plus 2. And the height is equal to 1, 2, 3. So we get negative, this would be 8. And then this would be minus 7.5. And that gives us negative 0.5. Right? Negative 1 half or negative 0.5. Then letter G. So go on ahead and try letter G on your own. And once you have found it, go back here and check your work. So you should get 4. Let's see, negative 8. Negative 8 to 6 would be equal to, I'll just put the area right here. So from negative to 8, that is equal to 1 half. Base is 2, height is 4, so that would be equal to 4. Okay, so I guess that's the only piece we're missing. And it's above the x-axis, so it would be positive 4. And then the semicircle, we found that out to be equal to negative 9 pi over 2. It's below the x-axis. And then the next one, let me just make this smaller. Okay. The next one would be this area here from 0 to 7. From 0 to 7, we have 20. And then from 7 to 13, where is our 7 to 13? You got 7 to 13, right? 7 to 13 is this part, which is equal to, let's see, that's 1 half times 6 plus 3 times 3 is 27 over 2. That's 13.5. So plus 13.5. And this gives us 424 plus 13.5. Oh, no, that's negative 13.5. Okay. So that would be 13 at 10.5 minus 9 pi over 2. Okay. Now, the next problem is no longer an area, but we want to find f prime of negative 6. So remember this is the graph of f. So at negative 6, you have a cusp, okay? So at negative 6, you have a cusp. So which means that, so let's write it down. So cusp at x equals negative 6. So f prime at negative 6 is undefined. Okay, what about the second derivative of f of 6? So f of 6 is right here. Now notice that this line, you have a straight line here, right? Which means that your slope is a constant, okay? So f prime is constant at x equals 6. And so if you get the second derivative or the derivative of f prime, the derivative of a constant would be equal to 0. Okay, letter J, the average rate of change in f over 0 to 5. So average rate of change, remember, this is the slope of the secant line. So we have to get f of 5 minus f of 0 divided by 5 minus 0. So f of 5 is equal to 4. F of 0 is equal to 0 over 5. So the average rate of change over 0 to 5 is 4 over 5. Okay, next. Oops. What did I do? Next one. The integral from 0 to 2 of f of x dx plus the integral from 2 to 4 of f of x dx is equal to the integral from 0 to 4 of f of x dx. So we are adding two integrals. So we get the integral from 0 to 2, right? It's here, 0 to 2. And then from 2 to 4, so this triangle plus the area of this rectangle here would be equal to the area of that whole thing. So that would be a true statement. Okay. Now next, over which values of x is f of x not differentiable? So whenever you have a point of discontinuity or whenever you have a corner or a cusp, then at that point, f of x is not differentiable. So that would be at x equals negative 6, or else at x is equal to 0, at x is equal to 2, you have a corner, at x is equal to 5, at x is equal to 7, okay? At x is equal to 8, and at x is equal to 11.